In this video, I'm going to talk about a couple of the major libraries that we're going to use whenever we're doing scientific computing on Python or any kind of mathematical or data science or any kind of that thing. Okay, and that's going to be NumPy, which I sometimes call NumPy to be strange. But anyway, so as it says here, it's a fundamental package for science computing with Python, and it's true. NumPy is at the heart of pretty much any tool set that you use in any kind of advanced Python programming, for sure. So what NumPy gives you, a couple of things. The main thing here are these powerful n-dimensional arrays. Okay, so we can do arrays. We can certainly do 2 and 3 dimension arrays in Python, basic Python, by using lists and list of lists and list of list of lists. Okay, but it gets a little cumbersome. It's not really designed for that. So NumPy is a much more streamlined way of doing that, in addition to having a whole lot of built-in functions to create and manipulate these giant matrices that you can do. Okay, there's also a lot of mathematical tools that come with it. Some things we can do they're really interesting. So we're going to take a look. Okay, and you can install this on your computer and run it in PyCharm. You're supposed to be able to install it directly from PyCharm, but mine was giving me trouble today for some reason, so I'm not sure what that's about. So we'll just use it within the Google Colab, and that works just fine. Okay, and then the other thing, and I don't know why I went to scatter because it was here. The other tool we're going to use that's used again everywhere is this matplotlib. Okay, and we use that to create really quick charts and graphs and all kinds of stuff. And if you can look through the examples in the area and just see that you can do just about whatever that you want to do with plotting. Okay, and we'll do just some real basics for that. Okay, so let me go ahead and get us over to the correct window to start looking at some of these examples. So again, the big thing we're talking about here is the NumPy, but we're going to use the matplotlib just to kind of show what we're talking about here. Okay, so we're going to start by importing NumPy as NP. This as is just a shorthand way to refer to it, and it is universally imported as NP. So just do this so people know what you're talking about. Okay, we can also import the matplotlib. In particular, the pyplot is what we're concerned with. Okay, so of all the things that we want to do, it's just the simple plotting we're going to do we'll be dealing with as PLT for plot. Okay, so once those are there, we can start creating some NP or NumPy arrays. Okay, so some of the built-in things that are kind of cool, we can create an array of zeros. Okay, and we can give that a dimension. Okay, we can then print that. Okay, print that out. It takes it a second to run. And it gives me an error. Oh, yep, that is a common error. I was giving it a size constraint, okay, and it really wants, which is okay, but I have to put that next to parentheses. That should do. Yep, that does it. Okay. So again, what it was expecting without that, let's do it a different way. I could do 3, and there we go. Okay, but if I want to do a multi-dimensional array, I have to do that. Okay, in fact, I could do that if I wanted to. I think. Let's see. Yeah, that's 3 dimensions, which gets a little confusing. So let's go with this. This will give us a 3x4 array of zeros. Okay. In a similar fashion, we can do 1s here. That's what you need. Same kind of a deal. Now they're all 1s. Okay. We can also use something similar to the range function. Okay, so we can say np.range, but it's a range. Okay, for array range. Okay, we have our beginning value, we're going to have our ending value, and we're going to have the step basically that we're going to create. Okay, if I do that, it gives me this one. Starts at 10, goes up to, but not including 30, and it's at step 5. Okay, so you can create them that way as well. we can also create random. Okay, so we can do an np.random .rand. Okay. Give it a 5, 5 there. That's going to give us a 5 by 5 array. Okay. And the numbers there are all between 0 and 1. Okay. So note that one of the other cool things that we can do, show this in a minute, I can do something like A2 is equal to 10 times A1, and then print A2. And what that will do for us, it will do only if I don't do an error. Should be a 10. There we go. That takes 10 times each element. Okay. There is a way to do normal matrix multiplication in this, but when you do the normal multiplication, it's just going to apply that to each element. It means we can do that to whatever kind of functions we want to do there. Okay. So this has generated random numbers in that range, and then it has gone through. And I should be able to put an int function around that. I think this may be going crazy. We'll see. No, can't do that. Okay. Yeah, there's again, I was trying to think, don't think. We're not in Python anymore with these arrays. We're in NumPy. So there's a way to do that, but I just did it the wrong way. Okay. So we can certainly do those things. Okay. Another powerful feature, we can reshape our arrays. Okay, so if we have something like b is equal to np dot a range of 12. Okay, then we're just going to print b. We have the numbers 0 to 11 in a range, no big deal. But let's say we want to turn this. So by shape, this is currently a 1 row, 12 columns. Let's say we want to turn it into a 3 by 4 array. Okay, we could say b is equal to np.reshape 3, 4. Okay, and then print b. And I've done something wrong. Oh, that's because, to me, NP is still a little bit strange, and I need to get the syntax right. This one does look weird. This actually looks like I want to reshape B to a 3 by 4. That's what I'm doing. You can tell I'm rusty. So it's like something. Should be B equals MP dot reshape B comma. There we go. Yeah, I had to put the B equals or it would not have made it permanent. The reshape returns an array, but I need to do this to be able to save that. There we go, all that, okay? So again, MP reshape, it takes an existing array, which is B, it converts it into a 3, 4, okay? Note that I should have been able to, from the start here, just have done a dot reshape. I think it looks like that. Don't quote me on that. Yeah, and that's the easier way if you knew you were going to do that. Okay, so it's attached to the B. Okay, and that works as well. Okay, so the reshaping turns out to be pretty handy. Okay, so now let's look at some basic mathematical operations that we can do in NumPy on our arrays. Okay, so if I have something like A is equal to np dot array, and this will take a list. So if we've got a 20, a 30, a 40, and a 50, for example. Okay, then we're going to let b equal to np dot a range 4. Okay, so let's just make sure we understand what we've got here. We've got print a, we've got print b. Okay, so let's see what we're dealing with here. Okay, so a has this, b has that. Okay, then again, this is going to output, any of these mathematical operations are going to output another array. So I can say C is equal to A plus B. Okay, then I can print C. And we see that this is 20 plus 0 is 20, 30 plus 1 is 31, and so forth. Okay. You can do any of the normal operations that you would expect there. Okay. Notice you can always do, I'll also do something a little crazy. You can do something like 10 times np dot sign, okay, of a. Okay, so we're going to take the sign of our a range there, and for every value in a, which is a 20, 30, 40, 50, we're going to multiply it by 10 times that range. Okay, so if you do that, you're going to get these numbers. Okay, and then if you wanted to yeah, that's the basic ideas there, that you can go through any of these arrays that you have, no matter how big. And as you see really quickly, although these are small, it will do those operations for you. Okay. Something else cool that we can do with our arrays once we have them. So we've got A and B now. We could do something like C is equal to, put a Boolean expression. Okay. If A is greater than 30. Okay. And if we print C, it applies that A greater than 30 to each of these. So it's false, false, true, true. Okay. And there's a way you can turn that back into a subset and all those things. But any kind of expression that you can think of, you can apply to these. Okay. So super powerful way to maintain things. Okay. So the last thing we're going to do, which is kind of cool, especially if you're more mathy, okay, we can use NumPy to plot functions. Okay, so let's say we're going to start. We want to have 1,000, say 10,000 data points here. One other thing I didn't mention, we can get this linspace function, and what it does, it's going to return evenly spaced numbers over a range. Okay, so we can automatically generate a whole bunch here. So in this case, we're going to go from 0 to 10 as our range. Okay, but we want there to be 1,000 intervals. Okay, so we can go ahead and put the n there. We're probably actually n plus 1, the whole fence post problem, but you get the idea. Okay, so if we do that, print x, okay, just see where we're at, you see that we're getting evenly, and it's just showing it automatically concatenates for us the beginning and the ending. So we start at 0, we go to 0 to the -3, and then 2 to the -10 to the -3, and so forth, all the way up to 1. That's just 1. No, 10. It's a 10. Sorry. So we're going from 0 to 10, but it's going up in an even spacing. Okay, which we're often going to use to print stuff out. Okay, we can then further create a y variable. Okay, so the x are the going to be the evenly spaced out numbers along the x-axis of a graph. Think of it in that way. Okay, let's say we're going to do something crazy here. We're going to do np dot, find my dot, exponent of -x divided by 10 times np dot sign of x. Okay, it's a pretty crazy looking thing for sure. Okay, but we can now do a plt dot plot x and y. Okay, we do that, it's going to generate this crazy looking graph for us. Okay, and we see here that we have, again, because our linspace goes between 0 and 10, we're good. Okay, we've got a nice smooth curve here because we're plotting a lot of points. Okay, so if I would change this to something really rough, we're going to get that, right? Okay, we still don't have enough points to deal with. But by going with something like a big set of numbers, we're able to smooth out that graph pretty substantially. Okay, Now, as long as my values stay in range, and sometimes they don't, but if I wanted to add something else, so say I want to say y is equal just to np dot, let's say the cosine of x, and then do the plt dot plot x and y, it will put both things on the same graph. Oh, they're in the same range. Okay, so we're able to graph that function as well. Okay, so this is really just kind of just touching the most basic things that we can do with NumPy and with Matplotlib. Okay, now my phone's talking to me again like it always does, but I do think it's interesting to look through the numpy.org and matplotlib.org to look at all the functionality that you have. We're going to certainly be using this more as we move into data science and move into scientific computing, things like that. Okay, so hopefully this was interesting and you'll take a look at this before class. If not, we'll talk about it a little bit tomorrow before we get going on the exercises.